Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. We're going to talk about how do we find area under the curve, but in this case, we're talking about the area between two curves. How do we go about it? Please make sure you review previous videos and rules. It's very important because I slowly build it up as I keep going down the series, okay? Before I proceed, don't forget to like, share, and subscribe. And make sure you click the notification bell so that when I post new videos, you'll be the first person to know. All right, let's get down to it. Like I always say that the area, when you integrate a curve or a line, it gives you the area from that curve or line to the x-axis, okay? And also, but in this case, we're going to be looking at two curves when they intersect. The last video we talked about a curve and a line, but now we're going to talk about two curves. Now, because I know some students do take notes, I'm gonna just quickly say the tip that I always say, that always remember, okay, that when you integrate a curve, or a line between two limits, so between the upper and lower limits, okay, it gives you the area of the curve from uh, from the curve to the x-axis. Like in some cases, it could be a line, all right, to the x-axis. So if it's above, it's going to be from that curve to the x-axis. If it's below, an area must always be positive, okay? Area must always be positive, all right? And if it's negative, ignore the negative sign. Okay, if negative, ignore the negative sign. All right, so let's get started. There are 5 steps to do this, all right? You can call it 5 rules, or it depends how you want to go about it. Now, the steps here are almost identical to the steps for when you have a curve and a line, all right? You find a point of intersection, you set the lower value for the lower limit, the upper value for the higher limit. You now sketch both the curve and the line. Then, but here it's going to be sketching what? 2 curves. Is that making sense? You're going to be sketching 2 curves. Then after that, you integrate the curves and you add or subtract the integral to get the area depending on where you are interested in, okay? So it's going to be exactly the same thing, but instead of having curves and line, you're going to have 2 curves. So if you understood the previous video about the area between a curve and a line, you pretty much get the same thing here. It's just that in this case, instead of you might have to do with polynomials or more advanced quadratic equation, but it's basically the same thing. All right, number 1. The first thing, like I said, you have to find the point of intersection. Okay, by equating the equation of the two curves. To solve for the value for x. So, like I said, what I did in coordinate geometry as well, you can also get the corresponding value for y as well, depending if the question asks you to find the x and y coordinates, okay? So basically, you just substitute the x coordinates into the original equation to get the y coordinates. Is that right? But normally, in this question, you don't really need the y coordinates, but just in case, there's no biggie, you can just throw it in here, okay? So you can get the corresponding y values if needed. So in some cases, you might not need it, okay? So you don't have to. So by substituting, okay, the values of x into any of the original equation. Okay? Number two, all right? You have to now set, when you now get the values for x, you now set the lower value of x as the lower limit and the higher value of x as the upper limit. Then you write the equation with the curve accordingly before you now proceed to start integrating, okay? So then number two, you set the value, or you set the lower value of x as the lower limit and the higher value of x as the upper limit. Okay? Then after that, you then rewrite the equation of both curves accordingly. So when you're done setting the lower values of x and the higher values of x, so you now sketch both curves to see the area covered by each curve using the upper and lower limit. So usually, like I always say, sketching is not really compulsory, but it's really, I strongly advise it because it helps you to visualize the area you're looking for, okay? So that's why I added it as one of the steps. So you sketch both curves to see the area. See the area covered by each curve. using the upper and lower limits. Number 4, after doing that, you now have to integrate the curve separately using the upper and lower limits to get the corresponding area value. Okay. So you then integrate the curve separately. Using the upper and lower limits. To get the corresponding area value. Number 5, when you're done with that, you subtract or add the integral, okay? Or you can subtract and add the integral you got from step 4 appropriately based on the sketch from step 3. So you subtract or add the integral results from step 4 based on the sketch from step 3. Okay, so this is the 5 steps that you need to know while doing it. So it's similar to the curves and the line when a curve and a line intersect. Okay, all right, so without much further ado, let me just go straight and pick an example for this. All right, so let's pick an example. So for example, we have let's say we have a curve like this, and we're told to solve this. All right, so let's see if we can have 2 curves. Let's make it a little bit more interesting. Let's say 2 quadratic curves, for instance. Let's use the 2 quadratic curves, and let's see if we're going to work with that. So let's assume we're told to find the area enclosed by these curves. So let's assume we have these 2 curves, and we're told to find the area enclosed by this. So we have y is equal to x squared minus 9. And we also have a second curve, y is equal to minus x squared plus 9. Okay, we have these 2 curves, and we're told to solve this. All right, so let's sketch this curve quickly. So like I said, in some exams, in some questions, the sketch of the curve will be given to you. In some questions, you need to sketch it yourself. So please get very conversant with the curve so that you'll be very, very sure and you'll not be taken by surprise in the exam. All right, so we have this, okay? We have the first one, then we have another one here. Let's say we have something here, okay? So we have this curve here. So let's make this one a bit longer. All right. And we're told to draw this. So x squared minus 9. So it's going to be a translation of in the 9 with 9 units in the y direction. So please, if you've not looked at my video on sketching quadratic curves, this will be a very good time to go and have a look at it again. So this is going to be this curve. So it's going to be the y will be equal to minus x squared plus 9. All right. So it's a translation by 9 units. Okay. In the y direction. Then we're going to do another one. We're going to pick the other one, x squared minus 9. So it's going to be a translation by 9 units in the negative x direction. So this is going to give you this, like this. Yep. So it's been 9 units here. Okay. So as you can see, there's going to be a point of intersection at this point here. Okay. The point of intersection at this point here, and there'll be another point of intersection at this point here. All right. So, and what do we need to do? We need to find that point of intersection. That is step 1. Okay. Step 1, we need to find the point of intersection. And as you know, at point of intersection, like what I said in coordinate geometry, y1 will be equal to y2. Okay. So, oh, I forgot to label this one. So this is going to be y will be equal to x squared minus what? Minus 9, all right? All right, so at point of intersection, y1 is equal to y2. So that means minus x squared plus 9 will be equal to x squared minus 9, okay? So that means x squared minus 9 will be equal to what? Minus x squared plus 9, all right? So I take minus x squared to that side, so it's going to be x squared plus x squared will be equal to take 9 to that side, 9 plus 9, all right? So this is going to give me 2x squared will be equal to what? 18. Then what do? You divide both sides by what? Divide both sides by 2. So x squared will be equal to what? 9. Now to get the value of x squared, we have to square root both sides. So we square root both sides. This will cancel that. So x is going to be equal to plus or minus 3. So therefore, x is going to be equal to 3 or minus 3. And that will be the answer for that. Okay? So the point of intersection is at x is equal to 3 and minus 3. So without being rocket science, you can know that this part is going to be the negative 3 here, while this part is going to be the positive what? 3. All right. Now, we're told to find the area enclosed. So basically, we need to find the area enclosed. I'm finding all this part all the way here. What is going to be the area for this? All right. So how do we do that? So we need to now make a sketch and try and break this down. All right. So let me see if I can copy all this. Copy this. Then come all the way down here and paste it here. Okay, so I'm going to use it later. So somewhere here. Good. All right, so now we can go back now. So for the blue one, minus x squared plus 9, the upper limit is going to be 3. The lower limit is going to be minus 3, right? So we can do that now. So for the blue one, step 2, we need to rewrite it, right? So we're going to rewrite it now. So step 2. So we have for the blue one, which was minus x squared plus 9. So the bigger number, the higher value is going to be upper limit. The lower value is going to be the lower limit. Then we also have another curve there, x squared minus 9. X squared minus 9. We have x squared minus 9. The upper value there is going to be 3, and the lower value is going to be minus 3. So the next step, we're going to have step 3. where we are trying to figure out breaking it into smaller area. All right. So let us together find where exactly, how do we find this region? So remember, the question wants us to find the area enclosed by this. So we're looking for what will be the area of all these parts here put together. So we're looking for the area of all this. Okay, that's what we're looking for. So how will you find it? Now, that is easy. Let's break it down step by step. So now, when we integrate between 3 and minus 3, the purple one, when we integrate between 3 and minus 3, the purple one, that is minus x squared plus 9, is going to give us from the line up to the x-axis. So remember, I always tell you, when you integrate a curve or a line, it gives you from that curve to the x-axis. So that means it's going to give us from this point all the way to the x-axis. Okay, it's going to give us all the way here to the x-axis. All right, so it's going to give us all this side together. Or let me make it evenly to make it pleasing to the eye. So you can make it like this all the way to the x-axis. So all this part is going to give you all this part till you get to the bottom of it. So from the x-axis, it's going to give you all this part to the x-axis. Are you seeing it? Now, what we then integrate the red one, between 3 and minus 3, that is x squared minus 9, is going to give you all these parts to the x-axis, to give you from the curve, the line, all the way to the x-axis. So we're going to give you all this part to the x-axis. Now, but we are looking for the green part. So that means the only way to get both of them is what? If we what? Add them together. So we'll add the area from the purple one and the area from the red one, and it's going to give us the sum of the total what? Area. Are you seeing it? That's the only way we can get the total what? Area for this. So let's go. Step 4 then. So let's start working on this. So we're going to solve the purple one. We're going to solve the red one, and we're going to add them what? Together. So step 4. So we're going to start with the purple one. So the purple one was 3 minus 3. So we're integrating between 3 minus 3 and minus x plus 9. And we have the red one, which was, we'll be integrating 3 minus 3, and we have x squared minus 9. All right. So we're going to solve them now. So as usual, we'll start with the purple one. We'll integrate this. It's just raised to power 1. There's going to be minus x. 1 plus 1 will give you 2 divided by 2 plus. Integrate 9 is going to give you 9x. And all between 3 and minus 3. All right. Then what do? You so remember we're adding here, right? So we should not forget what we're doing. We're adding both of them together, right? So what you're gonna do here is that we're gonna substitute x for 3. Then with minus 1, we substitute x for minus 3. So that will now give you minus 3 all squared divided by 2 plus 9, 3, okay, minus, we substitute minus 3, minus 3 all squared divided by 2 plus 9 minus 3. Are you seeing it? And when you solve all this in your calculator, it should give you 36 what? Units. All right. Now, we need to solve the red one now, okay? So the answer we get here, we need to add it to the red one. So let's solve the red one now. So let's go. We're going to integrate that. It's going to give us x. 2 plus 1 will give you 3 divided by what? Oh, I think I made a mistake here. So it's not x plus 9. I think it's x squared plus 9. So this is going to become x squared. So this is going to be x3 divided by what? 3. Okay. Yes. And this is going to give you x3. And this is also divided by what? 3. And it's going to be 3 as well. And it's going to be divided by 3. And let me check. Minus 1, 3 over 3 plus 9, 3, 3, 3. This is going to give, yep, same 36. Okay. So the same thing here. We're going to have x3 divided by 3 minus 9x. So this tells to show that it's very important that you be careful, because you can make silly mistakes in this kind of stuff. So when you're solving, it's good to go back and make sure you have a second look at what you're solving, because you can make silly errors here and there. So what do? You substitute 3 minus 1, you substitute minus 3. So it's going to give you 3 raised to the power of 3 divided by 3 minus 9, 3 minus, you open the brackets, minus 3 raised to the power of 3 divided by 3 minus 9 minus 3. All that. And when you solve that, it should give you minus what? 36. I remember I told you can't have negative, so that will give you what? 36. You ignore the negative sign, so it give you 36 units squared. Okay, units squared. Then when you're done with that, well, remember that to get the total area, you need to add both of them together. So step 5, the total area now, total area you're going to get is going to become 36 plus 36, and that will give us what? 72 units squared. And that will be the answer for that. Okay, and that will be that for that. So now that is how you find the area between two intersecting lines. So it could be in different forms. You can have it in several forms. It does not really matter. You can have it like this, like this one. You can have both of them like this, something like this. You can have it somehow. You can have it maybe like this, and like another like this, something like this. You can have it different ways. All have different ways. They're all the lines that are intersecting at different points. You can have it like this, a tool to find. So you have to play around with it. Okay, so you'll be having to look at what part of it you're interested in. Okay, in some cases, you can have it on the negative sides. So you can have it like this. So it does not really matter how the curves come around. What you need to know is that you have to shade it and know that when you find the area between a particular point, it gives you from that point up to the what? The x-axis. Is that okay? Yeah, it will give you from that point up to the x-axis. All right. And that will bring me to the end for area between two curves. Now, the next video, I'm going to go in straight into trapezium rule. And I'm going to talk about that briefly before we go to finding equations of a curve from its derivative. All right. So please don't forget to like, share, and subscribe. And it's important to click the notification bell so that when I upload these videos, you'll be the first person to know. All right. So I'll see you soon. I'll see you in the next video.